Okay, let me talk about my Unit 5. And in Unit 5, I talk about 2D motion. Now let's do a small recap because things have been a little bit scattered. Unit 1 is very introductory. Newton's laws, conservation laws. It sets some of the fundamentals for the course. Unit 2, I'm looking at what's happening with an object when there's no net force acting on it. I'm looking at the motion of the object. I'm looking at the energy, the momentum aspect of the object. In Unit 3, I say, okay, let's look at the same object, but now we do have a net force acting on it. I don't care what the net force is, it's just an unbalanced force. I look at the kinematics involved. I look at the energy involved. We look at the momentum or a change in momentum that gets involved. In Unit 4, I'm taking the same object and it has multiple forces acting on it. A pulling force, gravity, normal force, friction, whatever, angles. That's when I introduce vectors. Again, I look at the aspects from the kinematics, from the overall force aspect, from the energy aspect. Not much to deal with momentum in that unit. In Unit 5, I now introduce the idea of two-dimensional motion, which is projectile motion, or circular motion, and circular motion. I know a lot of people introduce projectile motion after doing 1D kinematics. I don't. The kids tend to struggle with vectors. And so I like to introduce some of the vector aspects of forces before throwing them into projectile motion, and it turns out pretty good. So my question is, what makes a body change direction? And this is really a simple idea. If you're going to change direction, you have to apply a force. Now, here's the thing. In my last unit, in Unit 4, I talked about parallel forces and I talked about perpendicular forces. The parallel force does work. It's a perpendicular force that changes the direction that the object is moving. And what we learned was the perpendicular force does no work on the object because it's the direction of the force and the direction of the displacement are perpendicular. That's why it's a perpendicular force. So perpendicular forces change the direction. Parallel forces speed it up, slow it down. Because there's only three things a body can do: speed up, slow down, or change direction. These are our three changes in velocity. Parallel forces account for two of those. This perpendicular force accounts for the changing the direction. So one of the things I talk about with 2D motion are perpendicular forces. So the big ideas for Unit 5, for two-dimensional motion. If a body has 2D motion, and quite honestly, it's simple to know that we have 2D motion because we're not moving in a straight line or it's turning, it's spinning. Let me take that back. Spinning connotates rotational motion. It's being twirled in a circle. So let me just be very careful about that. So let's look at the forces aspect with 2D motion. The perpendicular force changes direction. Okay. Now, if we have a perpendicular force, we have to have a perpendicular acceleration. The perpendicular acceleration is the sum of all our perpendicular forces divided by mass. Now, and this is a really huge idea. This perpendicular acceleration is in the same direction of the force. It's center seeking. Apologize for my writing. It's a centripetal acceleration, or associated with a centripetal force. And I'm going to talk more about centripetal forces later on. So the sum of all my perpendicular force is the centripetal force. When I talk about forces with Unit 5A, I'll talk more about this idea of centripetal force. In one aspect, it's very simple, and in another aspect, it's very confusing. It's the sum of all my radial forces. So, the sum of my perpendicular forces, sum of radial forces. Alright. From an energy aspect, the perpendicular force does no work because it's perpendicular to motion. And so we run into a lot of conservation of mechanical energy problems with circular motion. From a momentum aspect, what you have to keep in mind is that the momentum in the x direction and the momentum in the y direction are conserved. They're independent, they're conserved. Now, we don't get into two-dimensional momentum problems in Physics 1, but conceptually they do need to understand that. And so I'm going to put a little asterisk by that. So I really don't talk a whole lot about momentum as part of Unit 5, although I do talk about conceptually how momentum into 2D motion is conserved. So this is my intro to Unit 5. Let's take a quick look and let's jump into looking at the forces, which gets into the kinematics aspect of Unit 5.